Thank you. Well, in which case then, hello everybody. Good afternoon, good morning, good evening. And I guess with that, where are we in the world? I assume our attendees can use the chat, right? Let's have
Oh,
a
yes,
bit
yes.
a bit a bit of interaction here. Where are we, people? I'm over in the UK, so it is 9 p.m. over here. My day started at 6 a.m. this morning when my toddler decided that that was the time the day should be starting. So I've been going for 15 hours now. So I need some energy. I need some adrenaline from you. We need to get through this together, right? Because I've not had any more caffeine. So, oh wow, Australia. Okay, a lot of Toronto people. Yeah, I suppose as expected. Well, I guess Good evening for oh sorry, Austria, not Australia. Good. Okay. Thank you. Thank you for the interaction. Thank you for humouring me. And I guess kind of with that as well, we're a virtual event, and virtual events are always hard for the speaker, which is me, because I just have a webcam to interact with. I have no audience. I can't see your faces, which is sad because I miss speaking in front of a live audience. So what I would be asking now, like a show of hands, what is your experience working with Azure? And I'd be saying, what perhaps is your, say, job title? What do you consider yourself to be? So I'd be interested to know at least, that part of it. Are you a data engineer? Are you a data scientist? Are you an architect? Just to get a feel for the sort of people that we have on the call. Are you, I don't wish to disclose, I just go to work and hopefully somebody pays me. There's no wrong answers here. We're all friends. I would classify myself, I think, as a data engineer, absolutely, which more very much so, I guess, from an architectural perspective now, delivering solutions for my customers, but started out very much as a data engineer. I might even go as far as to say way back when I was an information analyst once upon a time. Okay, good. Thank you for the participation. It is appreciated. So hopefully you can see my slides, and we are here this evening for me to give you an introduction to Delta Lakes, which is hopefully an interesting topic based on where we are, particularly if you're a data engineer. Now, as our host has kindly said, yeah, my name is Paul Andrew. I'm a consultant. Apparently I'm now a technical architect that works within the Azure Centre of Excellence at this very orange consulting company that you may have come across before. But that's not why we're here. We're here to talk about Delta Lakes, and my contact details are at the bottom of this slide. I will share them again with you at the end. But let's now think about the topic at hand, and let's think about Delta Lakes. And because we're technical people, we don't like ambiguity. We want to be explicit with what we're talking about, or at least I do. So to overcome that first bit of ambiguity, the term delta. Now, when I say to my customers about a delta lake, they start thinking about the changes in their records, the changes since their data process last occurred. And to avoid any ambiguity here, what I'm saying is that we are not talking about the delta of changed records for a given process. It's not about that. It may involve working with those delta of changes, but that's not what we're talking about when we're talking about delta lakes. So maybe an obvious one given the context, but let's be explicit. And if there's any clever clogsers out there, we're also not thinking about the fourth letter in the Greek alphabet. So not those things. Good. If you like the slides that I'm going to show you, you are very welcome to them. They're not yet in GitHub. They will be in GitHub very soon. I don't think I've actually committed them yet, but there will be a PDF of these slides up there. As soon as I've finished talking, I'll go and do that. So grab a PDF of them and take them away and use those visuals and things if you wish. So the way I want to kind of break down our session is I'm not going to give you a full agenda. I kind of want to lead up to this, but I want to try and break down the session very much into two halves, if you like. And I want to start with the first half being focused on the theory. because it's an introduction session, we have to have a little bit of theory, a little bit of context, a little bit of background to this thing that we're talking about. So I'll start with that theory, and theory can sometimes be quite boring, I think. I definitely learn by doing. So we'll try and get through the theory as quickly as possible, and then obviously we can get a bit more hands-on and learn more about what a Delta Lake is by doing. So let's start with the first part here, theory 1.0. And we need to think about, to begin with, that background, we need to think about acid, okay? Acid. Now you're thinking, okay, what's he talking about? We're not talking about the sort of acid that you would get in the science lab at school, the sort of acid that would corrode your hands, or my wife's cooking might also corrode your hands. But we're not talking about that. Oh, there's no one laughing. I'm laughing. I might get told off in a minute. We're also not talking about the sort of acid that will make you do silly things. The recreational kind of acid. This picture, that's my first film reference of the evening from the film Human Traffic in 1999, which I personally find hilarious. So we're not talking about acid in those things. And again, let's avoid any ambiguity here. What we are, of course, talking about, and what hopefully you already know, is acid in the context of computer science. We want to have autonomicity, consistency, isolation, and durability. And this acid within computer science is something that we've long just come to expect. Certainly what we expect of our solutions to have this ability. And this ACID capability very much relates to our database transactions. These are properties of our database transactions. So with that then, and with that context of we're here to talk about ACID, let's think about now our databases and, how does this really apply? Well, within our friendly database, our database management system, our DBMS, what we've come to expect as these database technologies have matured over a good 20, 30 years, I think certainly longer than I've been around, but this computer science, this acidity, shall we say, what it's led to within these database technologies is a lot of very mature capability and that reliability of that data when we're working with them. So this ring that I've just put around this database is, just a few examples of what we now come to expect from a modern database technology, all backed by that theory of ACID having those transaction properties that underpin what this data is going to do when we put data in and out of it, and we merge it, we upsert it. And as I'm sure you know, these databases now come in lots of different forms. We can have elephant databases and we can have sea lion databases, all good fun. And when I started working within this industry as an analyst, a BI developer, if you like, I was very much working with a SQL Server database, an on-premises instance with its DBMS in there as part of that SQL Server suite. And we would use it to do lots of things with our data. So this was good, things were happy. We had our ACID and this is where we were heading. And then we thought, actually, what is better than one database? Any thoughts? Quick, fastest fingers first in the chat. What is better than one database? Again, just for my silly humor, because I'm all alone here this evening. No fastest fingers. Or maybe the chat's a bit laggy, is it? Hundreds of databases. Okay, yeah, close. What's better than one database? Two databases, of course. Of course, two databases.
Processing is the best. MPP.
MPP. Okay, yeah. Let's not get ahead of ourselves. We're going slow here. Not MPP just yet. So two databases are better than one, obviously. And with that, we thought, okay, well, what can we now do with two databases instead of just having one? And this is where we kind of went down this path of say, well, let's create a data warehouse. And what we can do with our first database is we can use it for online transactional processing, or OLTP. I'm sure you've come across it. And then with our other database, we will make a data warehouse out of it, and we will say that we're actually going to use it for what I like to call offline analytical processing. Offline in the sense that we're disconnected from the application. And what we'll do is we will build some process where we extract and we transform and we load. So, hopefully nothing too new here. But this is very much where we were heading and where we like to be. And if you like the Wikipedia references, then there's of course one for a data warehouse up there. And if you weren't already aware, we do consider Bill Inman as the father of the data warehouse. And what we have is basically a system for reporting and data analysis, which is all good. We want that because we want to get insight from our data, and we recognize hopefully the value in taking that transactional data, moving it into a data warehouse so we can do that analysis. And as data engineers, that is our problem, hopefully then to go and solve and to work on so our customers can get that data. So that's fine. So that was all good. And our database or databases were happy. And we had our ACID. Then along came the data lake, and use as many water-based metaphors as you like here. Somebody turned the tap on and made my database wet, if you like, maybe a bit labored. But we had our data lake, and we thought about our data lakes, and we thought, okay, is this a good thing? Is this a bad thing? And we thought about all of that good stuff that our databases used to give us or still give us. And actually, when we thought about all of those things, what happened was that our data lakes didn't really stack up. They served a purpose and they helped us with other stuff. And we could say complement things here when we talk about big data. I like to put it in quotes because I think it's more of a buzzword. It's very much a relative term, of course, big data. But we said, okay, our data lakes will support big data, whereas our traditional on-premises databases, maybe they didn't. And we talk about, of course, the 4 V's: volume, variety, velocity, and veracity. And yes, our data lakes can handle that, but they don't still give us some of that other stuff. When we think about the multi-process handling, yes, our data lakes will scale because the storage is now fundamentally different to what we had in our databases. We now have storage nodes that are distributed just by the very nature of what's underneath there, using the Hadoop file system in most cases. Our data structures, if we think about that variety, within our big data, our V's, yes, our data lakes can support any data structure, whether it's structured like a schema, structured or semi-structured like a JSON or XML, or even just blobs, whether it's an image or a binary file or whatever. Our data lakes can handle that. So we do get some good stuff here. And then the last one is that through our vendors or our cloud platforms or however we wish to create our data lakes, we can get quite a lot of redundancy just baked in by the nature of that distributed storage. So our data lakes were good, they were okay, but ultimately we missed our ACID, right? As this character from the film is obviously looking at our data lake thinking, maybe, but not quite. So to summarize that problem and hopefully to set the context for this talk, what I want to say is that our data lakes are good, but they still lack some of that basic ACID functionality needed for data processing, the acidity, if we're allowed to say that. And maybe just to sort of extend that problem and to avoid any ambiguity again, what we could say is the problem is that, are we trying to use data lakes for everything to replace our databases? Of course, they can't simply. So I've just put a table here of a few comparisons, but the one comparison I want us to call out and I want us to think about is on the bottom right here, is about having that storage and compute now decoupled by the nature of what we're doing here. And in computer science, we like things to be decoupled. We like to have that low coupling and high cohesion, which is fine. And certainly with our data lake, we get that because the storage is there on its own. There's no compute. So let's think about that and let's just park that for a moment then. So if that is the problem statement that our data lakes just miss that ACID capability, then the solution becomes quite obvious. Let's enable ACID transactional support for our data lakes. Yeah, just like that, let's just click my fingers and make that happen. So, this solution I think was fairly apparent, but the question then became how, because we have this scalability problem. We like our database, our DBMS solution, because it will scale up, and that's fine. But we also like our data lakes because our data lakes will scale out. That distribution effect, that parallel processing, which we've now come to need in this sort of more big data world. So with that, think, okay, well, how do we actually enable these database type transactional properties for our data lakes? And where we have that storage, very, very simplified here, very generic, which, as I've mentioned, will probably be using a Hadoop file system. Certainly if we're in Azure, it will be. And we've got that compute. And for the compute, we're going to be thinking about Spark with its Hive metastore. So we've got these things that are decoupled. Now, to enable this ACID, what I'm really saying is that we're now not coupling them, not tightly coupling them, but we're coupling them nonetheless, because we need that storage with that compute to give us this capability. So what I'm saying here is that actually the solution is our storage and our compute now working together again as friends. Which within our database management system, they were tightly coupled. It was part of the same package. Here we've got that distribution effect, and we need this to happen again. So with that then, let's now think about, okay, we know what the solution is. We understand roughly how we're going to implement it, where we couple that storage with that compute once more to gain these transactional properties and this ACID effect. And there was a few vendors, a few tech giants that did this. So let's start with the obvious one. Let's start with Databricks. Now, Databricks developed Delta Lake. Okay. Netflix developed Iceberg. And if you're curious about Netflix, there was a great video at the past summits, I think maybe 2017, where Netflix talked about their data warehouse. And it, phenomenal amounts of tech and processing and things that goes in there, and petabytes of data. So it was really quite interesting as a sort of side note. But anyway, so Netflix recognized this problem of missing the ACID as well, and they developed Iceberg. And lastly, Uber developed Apache Hudi. And these were all frameworks that meant that compute and storage became friends once more, and we got that ACID capability over our data lakes. Now, I don't work for Uber and I don't work for Netflix. I'm a consultant. So the obvious choice here for me when it comes to ACID is Delta Lakes, and hopefully given away by the title of the talk as well. So let's now think about what our Delta Lake is. Let's introduce it properly. And to do that, let's just kind of clear up and take a brief history lesson. Now, I say Delta Lake was developed by Databricks, but what's happened since Databricks developed it, they've actually now made it open source. So you can now go to, oh, could you mute, please?
You can get find out and muting.
You can now go to delta.io and get an open source implementation of this, which is what Databricks have now made available. And if you wish, you can use this open source Delta Lake on any Spark implementation. It's not that easy to install. A pet project of mine is trying to get a Kubernetes cluster running on some Raspberry Pis, installing Spark and installing Delta Lake, but it's proven challenging. It's not easy, but it is possible. So Databricks open sourced it, which was great. So we now have this open source set of libraries that we can add to our Spark implementation. We can use Delta Lake, we can get this ACID capability. So to answer that question directly, and quoting this from the Databricks blog, when we say what is Delta Lake? Delta Lake is an open source storage layer that brings ACID transactions to Apache Spark and big data workloads, quoting them directly. So that's what it is, and that's what we get. So all of that stuff that we missed from our databases now becomes available, which is great. Now, as I said, this is quite hard to implement on a Spark cluster if you had to do it yourself. So why not let somebody else do it? Why not let Microsoft do it, or somebody else that has a Spark implementation? Now, the obvious choice here, and hopefully this is where the history lesson comes to a close, that Databricks has for a long time now, since 2013, had their own implementation of Spark, where they've had lots of premium features and cluster management and lots of nice stuff that they've added to Spark. And Delta Lake is just one more example of that. But because this is open source, what you'll find is that Microsoft now also have their own implementations of it. And specifically when we're thinking about when we're working within the Azure environment that's not Databricks, we can use things like Azure Synapse Analytics with its Apache Spark compute pools. We can use data flows within our data factory that have connectors for our Delta tables. And if we wish, if we're using Spark within HD Insight, we can interact with these Delta tables as well. So we've gone from that open source technology to now having lots of options and implementations of it, which for a data engineer is great because we've got a lot of versatility here. We're not locked into any particular vendor when we come to actually working with our data, and we can create our tables and things with that transactional resilience. Now, the really interesting thing in hopefully what's coming is where these tech giants, Microsoft and Databricks, actually start doing their own pull requests and actually start contributing back to that open source standard that is Delta Lake. Now, for me, that's a very interesting question of what's going to happen next, because Databricks have obviously done the first step of making it open source. Now, what are Microsoft going to do to implement their version? So to perhaps ask the question directly that's probably on everybody's minds, which Spark implementation is better? And to be clear here, are we thinking about Spark implemented by Databricks in Azure, or are we thinking about Spark implemented by Microsoft wrapped up in their Synapse Analytics product? Now, I don't know the answer to this question yet, and we'll have our second film reference here from the Matrix, and I'm going to say this is very much like taking the red pill or the blue pill. If you're familiar with the Matrix, let's say that Spark is Morpheus in this scenario. I'll be Neo. I'll take that burden. And do I take the red pill or the blue pill here when it comes to my implementation of Spark within Azure, at least anyway? And we'll come back to this film reference again, but at this point, who knows? Anyway, let's move on. Let's go deeper then now into our Delta Lake, and let's think specifically about a Delta table, Delta Lake table. And we're still going to work within the Azure environment. And I'm going to say for the purposes of these slides, I took the red pill. I can't remember what the result of that was in the film, but let's say we're going to do this with Databricks. And in Azure, I have my data lake storage, my Gen 2 data lake storage with its hierarchical namespaces. And what we'll find is that if we're working with our Delta table on disk, we can actually see the structure of it. We can see what's in there. So what we'll find in our data lake is a folder which represents the table name, once we've created our Delta table. And we will have our _delta_log subfolder. And this is the important part, because it's those transactions that we need to order to gain that resilience over our data. And those transaction logs, when we look at them on disk, are JSON files. And I tried to simplify the contents of one of those JSON files for the purposes of this slide. And you will see something a little bit like this. This is, of course, a very simple one, and I tried to tidy up the JSON a little bit, but ran out of space in the slide. The key thing here is what I've tried to highlight in yellow. We've got these action items. The first attribute, or the first key value pair in this JSON transaction log. We've got what that transaction is doing over that data that we have within our data lake. So this is great. We can see the obvious ones about the metadata that's added. We can see the lines of data that are added as add and removes, and there's other stuff in here. And I've put in the slide just an excerpt from the Databricks blog that just has the narrative that goes around the 6 or so different actions that you'll get within your Delta Lake transaction log, because I think it's important to actually drill into this level and understand what's happening there. Now, that's within a single file, and of course for each set of transactions within our session, we will get another transaction file, another JSON file. I've put 4 zeros in here on my slide. I think we're up to 30 or so zeros that you might have on your first transaction log. We'll go and have a look in a minute. Now, these transaction log files, they aren't just JSON. What will happen when you add more of these, when you get to like your 10th transaction, I think is the default setting, you will also get a checkpoint file. So for the purposes of efficiency, when our compute comes in here and looks at those transactions, it will, instead of having to parse all of the JSON content that's there, it will have a Parquet checkpoint file as well. And if that checkpoint file exists, it's got a consolidation of all those other transactions, which will make interacting with the Delta table a lot easier. You'll also get a file with no extension, which is called, as you can see here, the last checkpoint. And that just contains the information about which checkpoint file we should be looking for. What was the last checkpoint that was done? Okay, so that resilience, and it's that transaction log that really gives us that, and that's perhaps the most important part of our Delta Lake, having those transaction logs sitting alongside our tables on our data lake storage. And that's not all, of course. Those are just the transaction logs. We need the data as well. Now, depending on how your table is partitioned, you will have some subfolders in here that represents that partitioning structure. I'll show you in the transaction log where that's identified and how we deal with that. But depending on that partitioning, you'll also have some subfolders within your data lake for those partitions, and they contain the Parquet files. So that actual data, the actual values in our table, are stored as Parquet on our data lake as well. And as we add more data, we will get more Parquet files. And as we remove data, it will be referenced in the transaction log to no longer include this file or that file. And it means that actually this can be quite noisy. It can be quite inefficient, because reading lots of little files with small amounts of data in is not the best way to handle our big data processing. So the other thing that you can do with your Delta tables, and what I'd encourage you to do, is an operation called optimize. So where you've got all of those little Parquet files with, say, 1 or 2 rows in, you can take them and move them into a large Parquet file. So again, just like a consolidation operation, very much like we had in the transaction logs. Now, that optimized capability is at the moment going to very much depend on that blue pill, red pill scenario. Databricks have an optimized capability out of the box because that's part of their premium features, part of their offering over Spark. But it's okay. We took the red pill in the scenario, so that's fine. We can do this. Optimize also spelt wrong with a Z, not an S. Anyway, now you'd think, okay, well, maybe we've done that. Maybe we've optimized our Delta table for performance reasons or whatever. Do we want to keep those other files lying around? Now, a great thing about having this transaction log and this resilience is that we get this time travel capability. It's genuinely called time travel. I think, brilliant, I can now time travel. And it means that what we can do is at any point in our the life cycle of our data and those transactions, we can say, yes, I want to time travel to this point, and it will give you those exact transactions at that point. It will also factor in any optimizations and checkpoints that have been done. But to be wary that you also have this capability here called vacuum. If you want to remove some of those old tables, then those old Parquet files, you no longer want them cluttering up your storage, you can remove them, but just be mindful of this when you're time traveling as well. But hey ho. So just to conclude and just to summarize that section, when we think about our Delta table now within our data lake, we get these subfolders. We can see what the content of this looks like on disk. And very simply, our Delta table within our Delta lake, I'm going to get tongue twisted by this by the end of the evening. We have a set of JSON transaction logs. We have a Parquet file. And this is how our data now lives in disk using this implementation over Spark. Good stuff. Now, when it comes to actually using Databricks and working with it, now we get all of the good stuff that we're used to when we use Databricks. We get the ability to write Scala, to write Python, to write Spark SQL as well. Now, I'm going to make the assumption that you're already familiar with Databricks. This is an introduction to Databricks. It's just the implementation of Spark that we're interested in. And just for the purpose of the slides, and there's a reference link to this at the end as well, we get all of the good stuff when we're interacting with our Delta Lake. And I've included these cheat sheets because, frankly, I use these cheat sheets myself. Not so much the Python one, but certainly the SQL one. And the thing to call out here is that in the middle there, it's that upsert behavior, that merge capability. Now, once upon a time before our Delta Lake existed, if somebody said to me, oh, we need to do a merge operation over our data lake, you just couldn't do it. It meant that we had to go and basically delete and reload that data because there was no row level update capability, no row level delete capability either, not without a lot of effort interacting with maybe CSV files at the time as well. So really, to call out the power of this, it's those transactions then combined with what we get from the Spark ecosystem that gives us this capability, which is really great. So let's change gears again now. And what I put in my title slide was, an introduction to data lake, but also then this concept of a lake house. Now, whether this is just buzzword bingo again and describing things differently, the big data, the cloud, all this stuff. But we understand that Delta Lake is that open source standard, and Databricks now tends to refer to it as their Lakehouse. So just to kind of explore what we mean there, if we come back to my two databases scenario, which very much used relational database systems at that point, really what I'm going to say is that our Lakehouse is just that replacement for our data warehouse. Play on words, we're taking our relational database that acted as our data warehouse. It is now a data lake, but it's a data lake that has that Delta capability, that ACID, those transactions that sit above it. Okay, so that's for me the Lakehouse. So with that, then the last kind of part of the theory here, the last thing that I want to say to you is that with that, the challenge that I now have is if we think about using a Lakehouse as the replacement to our data warehouse, and that's what we're going to be using for our data analytics, our data science, or whatever. The challenge and the question I then have is, do we still need to implement a Lambda architecture, or are we definitely now shifting more towards a Kappa architecture? Now, again, if these aren't terms you're familiar with, there's a link at the bottom of this slide to the Microsoft Documents page where they talk about Lambda and Kappa architectures. So I suggest you go in there, have a look at that. But what I'll do is I'll just simplify here for the purposes of this talk. And what we say is that within any big data, I don't like the big data part of this, but within any, I'll say, data warehouse type architecture, we've got, generally these very simplified things. We have our data sources, we have our data storage, we might have some real-time ingestion, we're probably going to have some batch processing, some stream data processing if we've got that real-time data coming in, optional, and we'll probably have an analytical store, a semantic layer that's created there. And at the end of it, we'll have our business users that get their analytics, that get their dashboards or whatever, and the whole thing is orchestrated. So, those boxes, very simplified, but very true of a lot of architectures when we're delivering data insight for our customers from left to right, from source system to dashboard, let's say. Now, when we slice and dice it and we think, okay, well, what does a Lambda version of that look like? We say that within a Lambda version, we have this very separated hot path or the speed layer and this cold path and this batch layer of data. And those things very much come in via separate technologies. We handle them and we serve them, and then we give that analytics to the person on the right-hand side of the solution. Fine. What we're then saying is that actually with a Kappa architecture, we're just simplifying that even further. We're saying that actually our technology now can handle dealing with this on a single platform. So we have our speed layer and our batch layer all handled by the same thing, all handled by the same compute, which means that in terms of the analytics and the output, it becomes really easy because we've got it all in one place. We've got that speed and batch together, so it's easier to handle. So 3 minutes on Lambda versus Kappa, but let's just dig into it a little bit more. And let's start very much on the Lambda side of it. The Lambda side where we were once upon a time with our friend Nathan Mars. If you don't have this book, then I'd recommend you go and get it. I do have this book. I actually checked it earlier. Page 14 is where we're talking about a Lambda architecture in there. And once upon a time, this involved using our Hadoop file system, our Storm stream layer. I just looked, I realized I've got that picture the wrong way round. We should have our Storm represented by the speed layer and the batch represented by HDFS. You all spotted that as well, right? So slide failure there. I'll change that before I publish it to GitHub, but the speed and the batch layer are the wrong way around there. Anyway, that was once upon a time. Then things moved on to where we were in Azure. And it looks like all of these slides are wrong in terms of speed and batch being the wrong way around. So apologies for that. But it meant that once upon a time when we're in Azure, and I'm deliberately using the old icons here. So what we're talking about is pre-Delta Lake. And what we have pre-Delta Lake in Azure was, yes, we might have our data lake storage still. We might have an instance of Databricks, and we might end up using something like a SQL data warehouse at the time to bring that speed layer and that batch layer together and serve it with those queries. That was fine. But now if we think more about the Kappa side of it, and unfortunately it doesn't matter where speed and batch are in the Kappa version, and we tidy up our technology stack. We have our data lake storage, we have our Spark compute, but now actually that middle portion of what we're doing here is all delivered and surfaced by our Delta Lake, by our Delta tables, because we can. What else do we need? the batch data and the streaming data can all land in this Delta table at the same time. It will deal with it. It'll have the transactional resilience to deal with it. And if we're in Azure maybe today, we might consider using an event hub as the endpoint to bring that speed data in. And we might consider using a data factory pipeline to bring that batch data in. And of course, we've got Databricks there acting as the compute. Fine, that's one option. If we're going to take the blue pill, we might still have an event hub. We might instead have our Synapse analytics solution. We might have some pipelines, which is very much still like Data Factory, but data integration pipelines. Now, the other advantage we get with Synapse is that on the right-hand side, when we think about the serving and the consumption, we can now also have the SQL capability delivered maybe by a SQL pool, what was a SQL data warehouse if we need it, or a SQL serverless pool instead. So these are the just kind of perhaps takeaway things to then go and think about. It's not just now that the Delta Lake has given us this ACID capability over our Data Lake store. It's now very much that differentiation between, well, are we still building Lambda architectures? Do we still need to build Lambda architectures, or are we now actually moving much more towards a Kappa style architecture just because we can, because of what the capability gives us? So with that, that is very much, I guess, the theory portion of this over with. Sorry if it took a little bit longer than I was hoping, but so I think it was important to set that stage, to have that background, okay? And certainly that background of why data lakes needed this capability. So now let's turn our attention to the fun stuff. Show me this. Let's see it in practice.
Paul, is it okay to ask one or two questions?
Yeah, as long as it's not about encryption of CSV files.
You saw that, okay.
I saw that one come up there.
Okay, then if you want to take that later, then I have other question related to, the last slide you shown. It means like we can clearly kind of avoid that our favorite SQL database, you think, in future when the Delta Lake is coming? So it's like we don't need SQL database?
No, I did caveat that. We still need a transactional database. Now, whether that transactional database is a SQL DB or it's Cosmos or something else, we do still need that transactional layer. I'm not saying we don't need a SQL DB. I'm saying that the Delta Lake is there in place of our warehouse to serve that data analytics.
Okay. Thank you.
So no, don't go quoting it as Paul says Delta Lakes replace databases. Not at all. It's a much more of a it depends type question. Anyway, let's see this stuff in action. So I'm actually going to start with the blue pill on this occasion. I'm going to start with Synapse, and the reason is that there's a nice set of code and stuff that's already created in here for you if you do go and have a look at Synapse. So if you go into the Knowledge Center and you go to the gallery and you go to notebooks and you put Delta in here, you get a getting started with Delta Lake set of notebooks in either in Python, in Scala, or in C#.net. So that's the one I'm going to show you in a minute. Just to be very clear as well, though, if you go to pipelines and think about Delta, we do have some example pipelines in here as well. Now, this is very much where we're talking about the delta of changes that's happened in our source system since our process last ran. So this is not about our Delta Lake, but our notebooks are. So I also like the fact that within Synapse, we can write C# over Spark because I'm old and I like C# and I like T-SQL. So if I was going to do this, I could go and open this notebook. I've not had to write any of this code. It's all done for me, and it will put it into my Synapse workspace. So I'd encourage you to maybe go and do this and go through it and have a look at it as well. What I've done ultimately, though, is here's one I made earlier. That's annoying that my my session's timed out, but what we'll do is I'm just going to kick this off. I'm not going to wait for it because it's not. I don't need to wait for it anyway, but let's close that and discard that. And let's just try running this again. And hopefully my session will go and start. But what we're doing in this notebook and with this code that you know, somebody at Microsoft's kindly written for me, as you can see, we're defining a session ID, just a random number, and we're defining the path for our delta table. And our delta table is originally called delta table with that session ID concatenated. So we're creating a delta table and we're writing it with a random range of stuff to our data lake storage. So in the context of Synapse, we already have some storage mounted and attached here. We've got that sort of unified environment, which is great. And this script is going to go away. It's going to create that delta table. It's going to put some values in it for me, and that's all good. I'm not going to talk through this notebook because you can have a play with it and look at it in your own time. The important thing that we do want to look at though is in our data lake storage, you know, because I really want us to look into, you know, what's happening here and what's being created. So we have in my syn files this delta directory, you know, referenced by that create path there, and we have a delta table, and we have that delta log. And you see here we've got those transactions. In the case of this one that I created earlier, we've got a checkpoint file. We've also got that last checkpoint file as well. So if I just go and download that, if I've not already got it on my desktop, I have already got it on my desktop. If we actually just go into that, save that for later, and we look at that on here, and we open our favorite notepad tool, which I've already got open, but we look at that transaction log. We see, you know, something that's fairly human readable, hopefully. Let's make it a bit bigger. We've got the initial commits. We've got that metadata. You know, in the case of that table that was being created, it only actually had one column. But you can see if I scroll to the right, we've got the schema, or the schema string as it's called. We've got the fields within that schema. We have a field that is named ID. It is the type of long in this case. Is it nullable? Yes, it can be nullable. We also have that partition columns, you know, which is very important when it comes to the structure of the rest of our delta table. Now, in the case of the one that I downloaded, it's not partitioned at all, which means that all of the transaction lines, the actual data, they get dumped into the root of that table folder without any subfolders. So there's, you know, there's no partitioning here on my table. But what we can do is if we look at then the transaction lines, so say we've got one, okay, we're adding a row to our table, and that row that's added references a Parquet file. So if I go and look at, I think the second one, the first one will actually be the column header. So if I then go and look at the second line in here, where's my friendly Parquet viewer? Oh, blast, I appear to have closed it. 1 second. If I get my friendly desktop Parquet viewer, if it chooses to open, it's gone over there. And I go and open that Parquet file referenced in this transaction log from my desktop in this one. You know, so I just copied it out of Notepad there just to make it easier in here, and I open it. We see something very exciting. a very exciting Parquet file that contains the column header, and it contains the value of 0, because that was the line item that was added by that Synapse notebook. So, fairly boring, but interesting to see that we can actually really drill into what this delta table is looking like and how it's constructed if we wish. Now, the second value was 1. Okay, that's also exciting. But anyway, let's do something more exciting then. So we can see on disk what the delta table looks like. We can hopefully see if my Spark session has started. In this case, we can run through this. What we can also then do is that, depending on where we've got to in here in the execution, I've modified this notebook a little bit just to add a few extra transactions and things. What I've done down the bottom of mine is I've now created a database. Creating them seems fine. Dropping them doesn't seem to work as well. So you'll see I've tried to drop this one, and it says you can't drop it because it's already in use. It's already got stuff in it. It definitely hasn't, but hey ho. We'll go for demo number 3, and I have to keep telling myself to do Shift and Enter to execute when we're working within Synapse, because it's of course Control and Enter when we're executing in Databricks. What are we saying here? What's wrong with you? Database already exists. Okay, thank you. So I've just created a database now, and this is very much a database within my Hive metastore. So I'm using SQL to create it, and you'll see that within Synapse we get a database called Spark, or a database with Spark in brackets, which is fine. And then I'm going to say, let's create me a delta table. Let's just grab the name of the one that was created as part of this session. So my delta table 955. And I very much prefer to interact with my delta tables using SQL, because why wouldn't you? Unless you're definitely a Python fan, which fine. So I can create a table using that delta location, and we can then go and query it, which it's not going to contain anything exciting, but it's just the fact we can query it with SQL, and we get that list of numbers, those transactions. Fine, but because we're in Synapse, what else can we now do? Because these tables are very flexible. Now, the preview feature that I just want to show you while we're in here, and it's something that Synapse can do that we can't do anywhere else at this point, is you'll notice that I also have a SQL database here, not a Spark database. Now, because we have different types of compute within Synapse, it means that those delta tables can be used in different ways, not just by the Apache Spark compute, but also by the serverless SQL pool as well. So I've created a Spark database, and that's where this table now lives in that Hive metastore. But if I open Management Studio and I connect to the serverless SQL pool instance that exists within Synapse, you'll see my demo 3 database there. And if I query it, well, what are we going to get? We get this Azure SQL RTM, this database. Okay, well, fine. But what we can actually do with our delta table is we can query it. But what I'll just show you is that we can't query it using the Hive metastore. Again, this is a preview feature that you can play with, because it says it's a replicated database. Okay, well, fine. So let's create a delta demo 4. So creating them is easy, deleting them doesn't seem to work as well. But and let's make sure we're using delta demo 4. So what I've now done is, using my Synapse serverless pool, I've got a delta demo 4 database. It's in the browser as well here, as now brackets SQL on the end. But it means that I can now create an external data source to my data lake, I can create an open row set. So I can do a select query if I actually call the right table name. Actually do a T-SQL select query over a Delta table, which, as far as data engineering capabilities go, and something that's what's wrong with you? Data lake, Delta, correct table name. Have I copied something incorrectly? Probably. Oh, let's have one more look. And if not, we'll use the one that I created earlier. Fine. So this having this capability to effectively query a Delta table using this SQL serverless pool within Synapse is definitely an advantage, because hopefully, as we know, a SQL serverless or a SQL endpoint is a lot more versatile when it comes to connecting to things like Excel or whatever. Lots of connectors can interact with SQL. But perhaps the other thing to call out as well is that at this point, we're no longer using that abstracted. Oh, yeah, we are. I was going to say that abstracted view. Normally, it just shows as a SQL database. Anyway, we can query our Delta Lake now with T-SQL, which is lovely. But because these tables are very versatile, we don't have to stop there. We can actually say, well, within our Databricks world, if that's what we want to use, our Delta Lake, it exists at the storage level, and then we can bring our own compute. So if we want to take the red pill, we can say, fine, let's go in here, let's query our Delta table. Don't hard code storage account keys directly within your notebook. That is very bad practice. But if you want to ignore that for the moment and say, fine, let's go in Databricks, and if this cluster's still running, we can create a Delta table within our Databricks Hive metastore as well. And we can work with that Delta table using this compute instead. And because we've got that transactional resilience and that consistency, that's fine. It's okay to do that. So the Delta Lake exists at the storage level. We decide which compute we want to use. Now, if we want to go, really silly with this and actually think about consuming our Delta Lake, if Power BI wants to respond for me and get some data, come on, Power BI. We could, if we wish, say, let's connect to Databricks, and let's just grab my cluster details. Cluster from the JDBC section. I'm sure you get the idea at this point, but we can then choose how we want to consume our Delta Lake. We've done our transformation using whatever. Let's just do direct query for now. So I guess the point I'm making here is it's not just about that transactional resilience that we get over our data lake. It's about how versatile that this now becomes when we start working with it. So I can load that data into Power BI using the Databricks connector as the compute and the abstraction over my Delta Lake. Eventually, when it decides to do it, my laptop decides to do it. While we're there, let's get some more data. my laptop, I think, has already gone to sleep this evening. It says, "What are you doing, you crazy person, working at 10 p.m.?"
You must be also tired. Do you want to take a very small question in the meantime? Or? Okay, so I'll do
that. I'm nearly done. So yeah, let's just that final point, because I want to, I guess, use this just to kind of ask the audience one final thing when we get to it. If I go into my Synapse workspace and I'm telling Power BI now just to interact with that serverless endpoint, direct query mode again, we're going to get that same data back. Let's use number 2, was it that was working? No, maybe not. Good. So let's just stick on the IDs from there and stick on the IDs from there. We're only doing selects at this point, but we could, if we wish, do. Now they've put them into the same visual. That's not going to work. We could do inserts and updates and mergers and things as well. And I'm sure there's perhaps lots of questions rattling around your head about, well, what's the performance like here of using Databricks, and that comes to that question of which Spark implementation is better, and definitely one to figure out later. If we I didn't want to summarize. Where's the non-summarize? Have they moved it again? No, let's just change it to a table. Then we don't need to summarize. I'm sure you get the idea, even if my abilities to use Power BI on my laptop are failing. But we're hitting that storage from 2 different compute methods now, and hopefully 2 very different prices in our Azure subscription as well, using the SQL serverless pool via Synapse or the Databricks compute that we've got. So yeah, 2 tables, 2 connections. So yeah, I'm kind of out of time, so let me just come back to the slides and just finish up fairly quickly. And what I want to say to you is, well, it's that consumption that I want to allude to and think about. So if we park our transactional database, our Delta Lake, to the side, and I say to you, if our goal now was analytics or creating a dashboard in Power BI or whatever, and we've got our Spark cluster there, whichever flavor it may be, and we've done that initial transformation or cleansing work, what do we then do on the right hand side of that line? Do we consume it directly? Do we go more traditional and create a semantic layer in analysis services? Lots of it depends questions here. Do we go just from the SQL layer, just using a SQL DB? Do we need that tabular or that multidimensional model in there? Do we go to Synapse, and do we use the Apache Spark compute with that serverless capability, or do we go for the full fat SQL pool data warehouse because we've got lots of facts and dimensions that we need to transform? Maybe. Or do we just stick with Databricks because we can deal with that transformation and that serving all in the same place? And of course, we get that Power BI connector as well. So what I've put on screen is options 1 through to 6. And if you don't mind, in the chat, I would be genuinely interested to know what you think about this technology and where we're at now as data engineers. So again, no wrong answers. Options 1, 2, 3, 4, 5, 6. What does this audience think? As a very informal poll. How do you determine the costs of each option? Lots of different ways, John. There's, it really depends. I'm going to say it depends on all these questions, I think now. It's going to come down to your data volume, the complexity of your transforms, what you actually need to get out of this data. So there's lots of hypotheticals here and lots of variables. It's just do people favor a particular technology stack, and hopefully what we've now learned about delta lakes and a delta table, what should we then do next? If some people are looking at it thinking, I'm not sure, well then good, I think, because that's the answer that I've kind of concluded. For a lot of my customers, Databricks was king, but certainly now what Microsoft are doing with Synapse, it becomes a lot more interesting. Yeah, 5 with a photon endpoint. Yeah. Ask a customer what skills they have in their team. Yeah, good shout, Camille. Could be one way to go about it. If your customer likes C# like I do, then maybe you might want to use Synapse. Yeah, so I don't think there's really any wrong answers here, but hopefully you might leave this intro session maybe with more questions than answers, which perhaps was kind of the point. So thank you for amusing me there and indulging that one. I'll just show you there's a lot of links and references and things that I've mentioned and things that I've talked about in here. So I've put them on a slide in here as well. And I guess then with that, folks, thank you very much for listening, and my contact details are here, so reach out to me, and thank you again for having me.
Thank you, Paul. Let's go through the question. I don't know, there was a question about that, the very first question, how to encrypt the CSV file in Data Lake or ADL Gen 2. I know this is not related to these topics, but if you'd like to answer that.
With Data Lake, you get encryption at rest as standard. If you're looking for like an additional layer of encryption or like double encryption with some sort of hardware key at the back end of it, then I'm sure there's support for that and bringing your own keys via Key Vault. But that's as far as my thinking would go at this point. Other than Data Lake is encrypted at rest, and then I'm sure you can configure additional things on top of it. But I'd have to go and check.
Okay. Thank you, Paul. The next one is from Arthur. Are Databricks and Delta Lake interchangeable technologies?
Are Databricks and Delta Lake interchangeable technologies? I wouldn't say interchangeable in that statement is the right word. Delta Lake is the open source standard, which just happened to be developed by Databricks, which I think is perhaps where the confusion is. So Delta Lake is that open standard, and that open standard can sit on an implementation of Apache Spark, which could be Databricks' implementation of it. So I think if I kind of jump back in my slides to maybe this one. Let's just bang through those animations. So we've got our Delta Lake, our open source standard. We've got an implementation of it with Databricks. And Databricks is using that open source standard, but it furnishes it with some premium stuff as well, like optimizations and like merge statements. Perhaps the better question would be, are Delta Lake tables interchangeable between one implementation of Spark and another, so Synapse and Databricks? And the answer to that is yes, they are, because it's that open source standard. And there's actually a link to a blog post of mine where I did exactly that. So as long as we're adhering to that open source standard and we're not expecting anything extra, then we're fine. Yeah, they are interchangeable.
Okay, thank you, Paul. Next one is from Ian. What is the justice show? How to open that Parquet file, the tools? Oh, I think Arthur already replied. It's you can get that tool to open the Parquet file from Microsoft, App Store. There is a standard Parquet viewer.
Yeah, I think the one in the Microsoft Store isn't supported anymore by whoever developed it. what I've put in the chat is the GitHub username of the person that I got their Parquet viewer from. I actually downloaded the source code and compiled it myself. So that's the one that I used, but I think there's a few out there. I don't think there's an official one.
Okay. Thank you, Paul. The next one is Delta Lake is part of AWS Gen 2?
No, it's not part of Data Lake. Delta Lake is, that storage and that ACID transactional layer that sits on top of your data lake. So it's about that compute and storage working together again. So it's not part of it. Yeah, the data lake is the storage, Spark is the compute, and Delta Lake is that implementation you get when both are working together to deliver these tables.
Okay. Can I add something to this question? I have when you were explaining it. For example, when you were working in ADF, so we can connect as a source the target to data lake. Now, can I connect to the target to the Delta Lake?
You can when you're using the data flows. So
Okay.
not with a copy activity, but if you use a data flow, you can. And the reason you can do that is because underneath a data flow is actually just a Spark implementation, which has the Delta Lake libraries installed on it.
Okay. Yeah. Thank you. I think the next question I asked there, it is more about the SQL pool you're talking about from Snaps, then from Delta Lake, and you got the data into the SQL pool. It's only possible in SQL pool, not really any standard Azure SQL database, right? Like any serverless database or any Azure SQL database, standard one, not the parallel processing one.
It's a capability of Synapse, whichever SQL flavor you tend to use. The querying the Delta tables with the serverless SQL pool, as it's currently known, that's the bit that's a preview feature at the moment. But it's a nice preview feature because having serverless, unmanaged compute to interact with a Delta table that sits in a data lake is very nice.
Yeah, the reason I was asking, Paul, because the SQL piece is so expensive. It's a parallel processing database, right? That's the one you're talking about, I believe.
Yeah, within Synapse, there's three flavors of compute: the Spark compute, the SQL pool, which was a SQL data warehouse, the massive parallel processing engine, or the serverless, the very lightweight compute. So I showed the serverless, the very lightweight one, querying a Delta table.
Okay, thank you. Then John asked, how do you determine the cost of each option? Did you already talk about that, right?
Yeah, that's a very much an it depends question. We could talk about that all day and still not arrive at an answer.
All right, then I'm coming back to Bruno. How's your experience dealing with constant changes and doing DevOps or like CI/CD in Databricks versus not?
Yeah, good question. It's a hard one. I think all of this cloud PaaS technology, certainly within Azure, doing DevOps on all of it can be a challenge if you've got a very complex environment or a very complex platform even. So it's my preference at the moment. I end up having a blend of YAML pipelines that do a mixture of PowerShell things and CLI things and templates from ARM templates with Bicep, with Terraform in there as well. And there's I don't think there is any good single way of doing it. But my only suggestion would be is have everything source controlled, have a very good branching strategy. So we'll use Git flow quite often, or a variation on Git flow if we've got lots of environments, and commit regularly and deploy regularly, with very small changes to pre-production and production. But yeah, the my experience is that it's hard, and there's for certainly enterprise environments, it takes a lot of effort and a lot of management and a lot of governance, regardless of whether it's Synapse or Databricks or any other cloud service that we've got at the moment. So there you go.
Yep, thank you, Paul. The last question I have, I think it's a very general question. Is there a return to data Slack channel or any offline group to discuss? Oh, it's maybe this question to me. Okay. No, unfortunately, we don't have anything like those channels to discuss. But if you're in the meetup group, you can always post any question. There is more than 500 people in that meetup organization, so someone can jump and answer your question. Definitely, please try that out. Yeah, that being said, I think with time-wise, it's perfect timing. We're almost there, 5:30. And thank you so much, everyone, for joining the session. And thank you, Paul. You're staying like almost midnight. No, it's at 10:30, I believe, right?
Yeah, 10:30. Yeah, it's fine.
Yeah, but thank you so much. Thank you, everyone. And
thanks a lot. Bye for now. Good night.
Yeah.
Good evening.
Bye-bye.
Good night.
Thanks.
Stay safe.
Cheers.
Thank you. Bye-bye.